This video will be covering the relationship of the graphs of f, f prime, and f double prime. In other words, the graph of the function, its first derivative, and its second derivative. So in sections 3.3 and 3.4, we talked about just f prime and what that means about f, increasing and decreasing, relative max and mins. And then in 3.4, we talked about f double prime, the second derivative, and what it tells us about the graph of f, concavity and points of inflection. So now we're going to put all of this together and talk about the relationships of all three of these kind of combined. So if we look at this first graph here, I want you to make sure you understand what you're looking at the graph of. We've been looking at graphs of f, but I want you to make sure you're seeing the graph of f prime, not of f. So it's going to be a little bit different. So the graph of f prime is shown at what values of x does f of x have a relative min or max. Okay, so if you hadn't seen that this was the graph of f prime, a lot of people would say, oh, there's a relative max at b, a relative min at c, and that would be obviously incorrect. It's not that easy. So you have the graph of f prime, and you want to know where f has relative max or min. So what I want you to think of is think about all those justifications that we made. The graph of f has a relative min or max at this value because f prime does what? So if you want a relative min or max, you're looking at where f prime changes sign. Now when we talk about f prime changing sign, or really any function changing sign, not its slopes changing or anything like that, but changing sign, we're talking about when we change, cross over the x-axis. So when we go from negative values here right before a, and then to positive values after a. So what I want you to create, if you're given a graph of f prime, is make a sign chart, much like we've been doing, because this graph is basically a glorified sign chart. So I'm going to put each of these values, a, b, c, and d, and then we're going to create a sign chart. So let's look at what's happening, first of all, at a, b, and c, and d. At a, the value is 0. At b, the value exists, and the value of the first derivative is a positive value. It's above the x-axis. I know you see a maximum occurs there. We're not looking at the slope of the graph. We're looking at f prime. Then at c, we bottom out, and bottom out, which doesn't matter about the sign, but it is at 0. So the value of c is 0, and then at d, we are above the x-axis as a positive. Okay, so again, we're looking at the sign of f prime. Then we're going to go through and look at each interval. So from 0 to a, this is below the x-axis, so that means that f prime is negative. Now make sure you understand what that means. F prime negative means f, the graph of f, is decreasing. So even though you see that f prime is increasing, because it's below the x-axis, it means the original graph of f is decreasing. From a to b, f prime is above the x-axis, so f is increasing, f prime is positive. From b to c, still above the x-axis, so even though you see it's decreasing, we're still above the x-axis, therefore positive. From c to d, still above the x-axis, positive, and then after d, still positive. So we made a sign chart for ourselves, and we want to see what it tells us about the graph of f. And specifically where we have relative mins and max of f. And you see we only have one occurrence, which is going to be right here at a. So f prime changes from negative to positive at a, therefore there's a relative minimum at a. So let's justify that answer. So f has a relative min at x equals a, because f prime changes from positive to negative. Okay, so just looking at a little bit different type of relationship. So now looking at the same graph, we're now going to talk about inflection points. So I know we're looking at the graph of f prime, but you can still tell things about the inflection points given f prime, because the inflection points are where the second derivative changes sign. So when the second derivative changes sign, it's when the first derivative changes from increasing to decreasing itself. So those max and mins now are actually going to be important. So right here and right here, b and c, my function f prime is changing from positive to negative. Therefore, the slope changes from positive to negative. So that means that f double prime changes from positive to negative. So right here, at a maximum f prime, it means we have a point of inflection of f. And again, f prime slope, or the second derivative, changes from negative to positive. Therefore, we would have a point of inflection here at C, or a change of concavity. All right, so we can do the sign chart also for f double prime, but I'm not going to do that for this one. You know what? Never mind. Let's go ahead and do that. Sorry. F double prime at A, B, B, C, and D. At A, F double prime is increasing, so that's going to be a positive. At B, F double prime is a slope of 0. At C, F double prime also has a slope of 0. At D, F double prime is increasing, so therefore positive. Okay, so we're only concerned for a point of inflection where f double prime is equal to 0 and changes signs. So let's just look at B and C. So before B, our graph of f prime is increasing, therefore the slope is positive. Between B and C, negative, and after C, positive. So we have a point of inflections at B and C. Now, I know I created this sign chart for f double prime, but in my justification, it's always very important to justify using the information that's given. What was given to us at the beginning of the problem is a graph. So we need to justify it in the graph of f prime. So we need to justify going back to f prime. So here's what we want to do. First, say f has points of inflection at x equals b and c, because now, when we were looking at 3.4, we were looking at the graph of f double prime, or the function of f double prime. So we said where f double prime changes sign. But now we're looking at the graph of f prime. And so we want to relate back to f prime. So what is f prime doing? Because f prime not changes sign. If you look at B and C, what's happening? We have mins and maxes there. Again, I don't want to say mins and maxes, but I want to talk about something changing. So what's changing? The slope is changing, or the graph is changing from increasing to decreasing. So what I like is to say f prime changes, and I guess I should say from increasing to decreasing, or vice versa, which that is acceptable. You can say vice versa, because we don't really necessarily care about increasing to decreasing or decreasing to increasing. We just care where there is a change for a point of inflection. So that occurs at B and C. So that's how I would justify that answer. So we want to draw pretty much a rough sketch of what's going on for f. So they give us an initial point, f is 0 is 1, and actually that should be, sorry, f of A is 0. So at A, we're going to put a point of 0, and then given all this information that we have, we can draw kind of a rough sketch so that we know from before A, our function is going to be decreasing, and that's the only place it's going to be decreasing is before A. Everywhere else is going to be increasing. If you look at the concavity is positive before A, and then after D it's still positive because the graphs are increasing. Okay, so let's draw a rough sketch. So before A, we're decreasing. So it doesn't really matter where I start. It's just a rough sketch of general curve. So I'm going to decrease. And also, according to my f double prime, we're concave up. So we want to draw a concave up curve that's decreasing. Okay, so something like that. After A, between A and B, we're increasing and concave up. But at B, we have a point of inflection. So we're going to change concavity at B. So we're concave up, and then we start to change concavity. So you can see that, how I've started to change concavity there. So now after B, we're concave down, but we're still increasing. And we're going to continue increasing the rest of the graph. So at C, we have another point of inflection, but instead of that being a maximum there, it's going to have a point of inflection and then change concavity to concave up, but still increasing. And then D will still be increasing. Okay, so it's something like this. Okay, the next example that we're going to look at is pretty common, commonly seen on the AP test. So it's a lot of information that you see on here, and you have to be able to analyze what's going on and know the relationships between F and F prime, or in this case, H prime, and H double prime. So first of all, reading this, the most important thing that you want to make sure of with this example is that the function h is continuous. Notice it does not say differentiable, and you can see here in the graph h prime at -1 does not exist. That means that this function is not differentiable, but it is important to note that it is continuous. So at this point where I'm not differentiable, I'm still continuous. That means I'm probably going to have a cusp happening there. So they give us some information. They tell us from -3 to 3, they tell us that h of -3 is 4, so they're giving me an endpoint there, and my endpoint on the other side is at 1. And then we have the properties given below. So part A says, what are the x coordinates? We don't care about y coordinates because you notice here I'm given no graphs and no functions. So we want just the x coordinates of all, here's an important word, absolute max and min. We're not talking about just relative now. We're talking about the absolute, which remember, absolute can occur on a closed interval. And one of those max and mins could be at the interval, or the endpoints. So what I'm going to do is I'm going to kind of redraw this graph, or take all this information from this table and draw it in a sign chart. So we're talking about absolute max and min, so we're not going to look at h double prime here. We're just going to look at h prime. So I'm going to draw a sign chart. So we know that our endpoints are at -3 and 3. And we have these intervals going on here, and it looks like at -1, we do not exist. So I'm going to draw that. And at +1, our slope is 0. So then let's look at the information. It says from -3 to -1, the first derivative is positive. From -1 to 1, the first derivative is negative. 1 to 3, we're still negative. So what that means about h is that it's increasing, then decreasing, and then continuing decreasing. So we want to find where we have absolute max and mins. So what's happening here where it's undefined, what's probably happening is some sort of cusp here, which a max can occur at a cusp, which is fine. So if we want to talk about the absolute max and min, we can't just plug in values. We know that h of -3 is 4, and then from 4, it's going to go up. Then after -1, it's going to go down, and then it's going to go down still. So our absolute maximum is going to be where that relative maximum is at -1, because we're only increasing. So absolute maximum at x equals -1. There we go. Okay. Let's see. Hold on. Because, what I would say to justify, because on the interval from -3 to -1, h is increasing, then strictly decreases. Decreases. Okay. So we're increasing, and then we're strictly decreasing. So the absolute max is going to occur at -1. Now, what I'm going to do now is I'm going to erase this so that I have room. So make sure you have that down, and then I'll come back and do the absolute min. Okay, so now for the absolute minimum. We know that h prime of -3 is at 4. We increase to an absolute max, and then we decrease and then decrease some more. So if we didn't know what this endpoint at 3 was, we could not actually tell what was the absolute minimum, because it could be at -3, because I don't know how much I decrease. The only reason I know what happens is because at h of 3 is 1. So I know that I do decrease down past 4. So my absolute minimum is going to occur at x equals 3. Because I would state somehow that I know that h of -3 is greater than h of 3. And after x equals -1, h is strictly decreasing. So what that means is I don't come up and then go back down again. So that -1, or at 3, sorry, is the smallest value. Okay, so now we're going to talk about the second derivative. What are the x-coordinates of all the points of inflection? So we're going to do the same thing. We're going to create a sign chart based on the information off of the graph. So now for h double prime, we have from -3 to 3, and -1 and 1. So we're undefined here at -1 and 0 here at 1, same as the graph for h prime. But then between -3 and -1, h double prime is positive, which means that h itself is concave up. Between -1 and 1, it's positive, which means that h is still concave up. So that means no point of inflection there. And then on our last interval, negative, therefore concave down for h. So the only point of inflection that we have is going to be here. Okay, so we have point of inflection at x equals 1 because h double prime changes sign. That one's not too bad. That one's pretty easy. Okay, so now based on this information, so now we have all these points, we're going to sketch a rough graph of h. So they gave us the points -3, 4, and 3, 1. So we're going to graph those, -3, 4, and 3, 1. And then I know that I have a maximum that occurs at -1. So we're going to be above 4. So I'm going to kind of come off this graph for a little bit. And remember at -1 we talked about there being a cusp. And also look at the concavity. The concavity between -3 and -1 is positive. So we're going to be concave up and increasing from -3 to 1. So it's going to look something like that. Then at 1 we have a cusp, and it's going to be still concave up, but decreasing until we get to 1. So at 1, I'm just going to make some kind of arbitrary point. It really doesn't matter that I'm going to come to. So concave up, but decreasing. Then at 1, we have a point of inflection. So that means we're going to change concavity. So the graph will now be concave down, and let's look at what it is, and decreasing. So concave down and decreasing will look something like that. Okay, so hopefully yours is a little bit smoother curve than mine, but that's what your graph should look like. So most of this section can actually go along with section 3.5 in your textbook, and it has to do with curve sketching. So looking at all the information of f, f prime, f double prime, we can create a pretty good sketch of the curve that we want, and that's what section 3.5 is.